Hey guys, welcome to my physics screencast. It's basically going to be a revision on transformation versus transfers of energy for anyone who's still confused from what we learned in class. So to start off with, we have the system and we have the surroundings. We basically need to first define our system, and we can do so by asking some simple questions. First, what objects will be inside our system? What objects are in the surroundings? How do each of these objects affect the scenario? What energies are we taking into account? And how do these energies change depending on the contents of our system? Basically, any object that we put inside or outside of the system can essentially change the type of energy that is interacting with the objects involved, and also cause work to occur. In thinking about systems, Earth is always an important factor. Earth is either inside or outside of the system. When Earth is inside of the system versus when Earth is outside of the system or on the surroundings, the types of energy change from a transformation of energy versus a transfer of energy. When Earth is inside the system, it creates this energy called gravitational potential energy. Gravitational potential energy is, for example, if we had a roller coaster and we define the system to be the roller coaster and the Earth inside the system, then as the roller coaster increases in altitude, its gravitational potential energy increases because Earth, as it increases in altitude, it has a greater potential to fall back to Earth. Energy in this case is transformed from one form to another. When a roller coaster is at the top of a hill and slowly starts to come down, energy is transformed from potential energy to kinetic energy. A transformation of energy is energy constant, of course, because energy is never lost, and is changed from one form to another form of energy in an equal manner. Therefore, if potential energy is changed to kinetic energy, all of this energy will be changed to kinetic energy, or in essence, maybe some might be released as heat, but all the energy will be transformed, none will be lost. Now, if Earth is on the surroundings, this means that work will be done on the system. Basically, gravity pulls objects down to the Earth, and Earth can only have this pull if it's inside the system. It can only have an effect on this object, a gravitational effect on this object, if it's inside the system. But if it's outside of the system, that means it's an external force. It's now an external object, and therefore causes work or transfers its energy to an object. Another example is if, say, I were to pick up a book. Now I am transferring my energy to the book. It is not changing the energy. A transfer of energy is maintaining the same type of energy, but transferring it between objects. Another example of a transfer of energy is if heat energy were to be transferred from hot water to cold water. Basically, the difference between a transfer and a transformation of energy is extremely important when thinking about the types of energy that are going on inside a situation. Now, while we are defining our system, we do have the freedom of choosing whether Earth will be inside the system or outside of the system. But for the sake of consistency, if we say Earth is inside the system, we should mention the transform of energy, and if it's on the surroundings, the transfer of energy. Another example of the transformation of energy, or rather, instead of Earth being the factor, say we were to take an example of a slingshot. In the case of a slingshot, now Earth isn't really the force, because in a slingshot it's more about the horizontal movement of the object. So if we were to define our system now as the ball that will be launched and the elastic of the slingshot, now if both of them are inside the system, this creates what's called a elastic potential energy. So in essence, as an analogy, if Earth is inside the system, there's gravitational potential energy. If Earth is outside the system, it's work. If the elastic is inside the system of a slingshot, then it's elastic potential energy. If it's outside, then it's work once again. So basically, transfer means passing of energy without changing the energy, and transform is to actually change the energy from one form to another. Now, as I said before, knowing the types of energy is really important, especially when solving problems to do with work and energy, because at least in the early stages, we will be using bar charts to help us solve these problems. And if our bar charts don't have consistency, then we ourselves may be confused when doing the problems. And uh, when we're using bar charts, which is basically a method of creating a mathematical model to write our equations at the end, when using these bar charts, we want to make sure we have the right types of energy so that regardless of whether we defined our system to be with Earth inside or outside, that we get consistent answers. Um, Basically, these bar charts, they'll be very important when we're solving for work and energy questions, and understanding the basics of transfer versus transform and what happens when objects are inside or outside a system will be very important and is important to know.